For this video, we're going to continue on with Chapter 2, and for my Chem 101 students, we're going to talk about mass percent and mass ratio. And this is a Chapter 2 problem from your homework. It's number 44. So in the problem, they state that it's known that ammonia, which has a formula of NH3, is 82.2% nitrogen by mass. Perfect. So they're asking if 22.5 grams of nitrogen are combined with 4.87 grams of hydrogen, what's the mass of the final product, NH3, ammonia? So, kind of made a mess. So this is saying they didn't specify that we're going to have any nitrogen or hydrogen left over. They should. So if they don't, we're just going to assume that they both combine to make the final product. So really, we're just going to use the law of conservation of mass here, and we're going to say 22.5 grams plus 4.87 grams equals, and we type that into our calculator, we're going to get 27.4 grams of NH3. The reason why is this is the mass of nitrogen, this is the mass of hydrogen. The next step here is where we get a little tricky. So they give us a mass of hydrogen and they say how much nitrogen is needed. So how much nitrogen is needed to fully consume, to react completely with 10.5 grams of hydrogen. This is where we use that mass ratio. This is a mass ratio. So one thing that we can do is we can establish that if it's 82.2% by mass nitrogen, it must be 17.8% by mass of hydrogen, right? Because there's only nitrogen and hydrogen in the compound. So with that information, why don't we assume 100 grams? So now let's make a ratio. We have 82.2 grams of nitrogen for every 17.8 grams of hydrogen. Now, you guys know how to cross multiply, and we're pretty comfortable with that. So in this fraction over here, we're going to say I have 10.5 grams of hydrogen. I want to know how much grams of nitrogen. With me? So you multiply, cross multiply. So it's going to be 82.2 times 10.5. We get 863.1, and that's going to equal 17.8 times x. Now to solve for x, we just take 863 divided by 17.8. And we get 48.5. And that's grams of nitrogen. Perfect. So the last part, I think, C of this question, because it is a multiple part question, is it says, what's the mass of that reaction? So this second reaction that we're talking about. This one. Well, the mass of the reaction of the product, right? It's going to be the mass of nitrogen and hydrogen added together, because all we're doing is adding 48.5 grams of nitrogen and 10.5 grams of hydrogen. If I type that in my calculator, I get 59.0 grams of the final product, the NH3. So the last part, the last question that they have is the one where we get a little tricky, and that's okay, we can handle that. So I'm going to switch out the papers. So their question here is, if we start with 13.0 grams of nitrogen and 2.00 grams of hydrogen, they want to know how much nitrogen is left over. Right? Let me triple check. Yep, they want to know how much nitrogen is left over. So this may look a little scary, but it's actually not. Our goal is they want to know how much nitrogen is left over. So that means that all of this is going to be used up. That means all the hydrogen is going to be used up. So what we do is let's determine how much nitrogen we would need to react 2 grams of hydrogen. So we would start with that ratio that we have. The 82.2 grams of nitrogen are needed for every 17.8 grams of hydrogen. Now I'm going to calculate. We don't know how much nitrogen we need for 2.00 grams of hydrogen. So then all we do is we cross multiply again. We get 17.8x, right, is equal to 2 times 82.2, 164.4. And then we take 164.4 and we divide by 17.8. We get x equals 9.2, we won't round too early, we'll say 9.24 grams of nitrogen. So this means we need 9.24 grams of nitrogen to react with 2 grams of hydrogen. All right. But we're given how much? We're given 13. That's way too much. So we only need 9.24. We're given 13. So what do? We say 13.0 minus our 9.24 grams. Right? This is what we're given. This is what we need. And we're going to find out how much is left over. .76 of nitrogen is left over. So go forth and do well. I believe in you guys.